We're at gotomath.com. Sorry for the delay there. We got the second fundamental theorem of calculus. This is like take 5. Uh, had some programming issues. Use the second fundamental theorem of calculus to find f prime of x. So I promised you that we're going to finally state the fundamental theorem, do a derivation or two, give you some kind of explanation on what's going on here. So let me go ahead and take 2 seconds here, write this down. We got the integral going from 6 to 2x plus 1 t squared plus 6 dt dt, right? All right, let's go to the whiteboard here, and we'll go ahead and write this down first before we get into the second fundamental theorem. 6 to 2x plus 1, and we have t squared. So like I said, they're going to give you one that you just can't take the integral of, because if you could take the integral of it, well, you could take the integral of it and then take the derivative and be done. Then again, usually calculus tests, you don't have time to do all that kind of stuff. Like I said, should be a 5-second problem or less. Okay, so let's go ahead and talk about this second fundamental theorem of calculus. The second fundamental theorem of calculus. I'm just kidding. Anyway, we're gonna the second fundamental theorem of calculus. All right, try to save some time on that. We have if f. We say if f. Usually I say let f, whatever, be continuous. If f is continuous, so we'll just write that out. Continuous. You know, usually most of these theorems, you know, f has got to be continuous on some interval. On an open interval, on an open interval I, let's say. The interval we'll call I, containing a, containing a. A is usually your lower bound, okay? Containing a, if you're wondering what that is. Then for every, or for every x in the interval, wish I could write a little neater on this bamboo pad here, but then we could say this, that d over dx, the integral going from a to x of f of x, oh, I'm sorry, f of t, this is f of t dt, that's f of t, man, that is a mess, f of t dt is equal to f of x. So right, so when we take the derivative, or when we take the integral of this thing, and then turn around, remember I said, well, anytime you take the integral, if you want to check your answer, you just take the derivative of it, and then you end up getting back the integrand. You end up getting back the integrand, right? So there you go. Also, you know, the fundamental theorem of calculus, I shouldn't actually state all this, but this would be, for example, f of x minus f of a, right? And then if you were taking the derivative of this thing, we'd end up with f prime of x, and of course this is just a constant, and this would go to 0, But what happens when this is a function inside, we use the chain rule. In other words, if this is like x squared in here, we would end up having to use the chain rule where we'd write f prime of x times, and then the derivative of whatever the inside is right here. Okay, so that's actually where I'm going at next with with all this. So in other words, f prime of x, and this would be like the chain rule part, like if this was f, let u, or I should let u be some function, and if we were taking the derivative of this is f prime of u times u prime. This is part of, right, that chain rule. But okay, so in other words, we could write df over, another way of writing that is df over du, and du over dx. So this is just basically another way of writing this up here, except this is going to go more along with what I've got written here, right? So I can actually rewrite this as d over du, and this is f of x, okay, times du over dx. Remember, this is still all equal to f prime of x. Well, this part right here, you see this part right here, okay, is part of that fundamental theorem of calculus, as you can see right here, okay. Except pretend that this is an x right here, right? Pretend that that part right there basically is basically an x. But anyway, if we're trying to compare it to this over here, so is equal to, now f of x. What is f of x? It's all of this up here, right? Remember, this is equal to, we were saying is equal to f of x, even though I didn't write it. So we have d over du, replacing this f of x with 6 2x plus 1, and so we have t squared over t squared plus 6 dt, right? And we still have the du over dx here, du over dx, okay? See that? Now, where in the world is the u at? Well, that's something that we need to come up with at this point right now. So let's scroll up the screen a little bit. So if I were to let u, let's do a little partition here, u is equal to this guy right up here. So this is 2x plus 1, and then du over dx is equal to 2, right? The derivative of this right here, okay, right? So this is going to end up being the substitution part. So I'm going to actually rewrite this as d over du, and then we have the integral going from, right, this is our a right here, going from 6 to u, and then t squared over t squared plus 6 dt. And I'm just going to go ahead and continue to write du over dx here. All right. So this is our second fundamental theorem of calculus, really, right here. So you notice, okay, pretend, I think I said this earlier and I didn't really mean to say this, but we're looking at this right here, all right, and that's what we've got going on here. This right here is our f of t, then our dt, right? And this x and x, both these variables are the same, so just pretend this is an x and that's an x right there, okay? And then what we're going to do is write, what do we got here? So x really is u, okay? X is the u right here, so let's keep that in mind. F of u, really, okay? And so we go ahead and now just write the integrand, but in terms of u, write the integrand the integrand in terms of u. Okay, so this becomes u squared over u squared plus 6, right? Now we're doing that substitution part, so du over dx is equal to 2, so I'm going to put the 2 right out here. Okay, and what is this all equal to? F prime, whoops, this is still f prime of x, even though it's in terms of u, as we said. But then what we want to do is go ahead now and rewrite as a function of x. Go ahead and rewrite it as a function of x. So f prime of x is equal to, so the u is equal to 2x plus 1, 2x plus 1 quantity squared over, right? And then we have 2x plus 1 quantity squared plus 6, okay, plus 6. And then of course you can take this 2 and just bring it out front out here, right? So what did we do? All we did was rewrote the integrand, but this time we made sure we replaced the t with whatever this is up here, right? And then took the derivative of this and brought it out front. I mean, in short, that's all we're doing. Okay, but then this is what somewhat of an explanation, I hope, of actually what's going on. I kind of actually like this right here, you know. But anyway, so this is a explanation of actually how we're even getting there using that second fundamental theorem of calculus. So let's go back to the answer. You're probably like, man, I don't know what just happened, but I do know the shortcut. That's what everybody wants to know. You know, what's the damn shortcut to this thing? Anyway, so there it is. Come on by, practice that. And where are we at? Let's go back home. I think the next one are a bunch of trig problems that you're probably not doing trig, but anyway, in fact, you could do it. I mean, you can do the problem whether you know trig or not. Okay.